in data, there is like two trends. One trend is obviously there's so much excitement, so much infrastructure built around deep learning. And I think from the outsider, it may seem like deep learning is the answer to absolutely everything. But then when you talk to actually, practitioners who are super deeply involved in certain forecasting problems, like for example, like UMax, then we see the sort of comeback to time-proven methods that were invented years ago and used by econometricians and statisticians for years. And I think I also came across an article recently that said that some of the better, the most, I think, like generally applicable and high performing model for tabular data is actually a decision tree for variations of decision tree versus actually deep learning. So I think it's kind of the contrarian trend to all the deep learning excitement. Cool. So that's it with our lightning talks. I would like to invite all our speakers to join the panel. So you don't forget to unmute yourself if you're speaking. So I have a few follow-up questions related to the lightning talks that I think are interesting to double down on. So one is data contracts. I think the way I understand the value of data contracts is kind of twofold. One is obviously we want to get reliable data, and then the how of data contract is basically if you have a formally defined contract which basically describes what kind of data, by whom, when, in what format is produced, then whenever this changes, you can have reliable change management and avoid surprises. And second, you can do more like automated discovery and understanding of those data assets by other people. I think what's also like not obvious, maybe obvious even, is that from the slide that Chad showed, it's a really, really complex system. And it seems to be focusing on the kind of the streaming part, the generation of data by services, basically emitting events in lots of different events at high velocity, but potentially transactional exports. But I'm curious how we think about application of data contracts for more one, like conventional data platforms. So if you're not running as complex architecture, how that applies to you, and two, how does it apply to non-streaming world? So should we supposed to have data contracts for data which is in Snowflake, like tables that we build, right? So really curious to hear thoughts from you, Daniel, since you worked on this problem, but also from our data practitioners guests today.
Yeah, I can definitely speak a little bit to kind of what we've done at Convoy. So I think you kind of hit it on the nail on the head, which is that we kind of started off with the data contract journey of we wanted to make data more reliable. And before we took advantage of any kind of streaming platform, our goal first and foremost was to get engineers on the production side and the data engineers and data science folks on the data side to just kind of come together, figure out what our production use cases were, and then kind of agree to what is going to be produced and how it's going to be produced. All of the additional streaming complexity stuff came either we were taking advantage of existing infrastructure at Convoy that we were using, or we were building things to solve specific problems that we ran into at Convoy. So for example, we wanted to basically be able to take advantage of an abstraction layer where even if engineers on the production side wanted to change the underlying database, we still wanted to give them a surface to be able to emit events or produce events in a standard kind of shape that they had been agreed to. And we had this streaming infrastructure kind of set up already, so we took advantage of that. So yeah, but that being said, we kind of started first and foremost with the problem is let's agree to a shape and detect changes before they are actually pushed. And so that part doesn't necessarily need to take advantage of the streaming aspect. It's kind of the initial gatekeeping of kind of how you get reliable data. Yeah.
I think on the point of non-streaming data, I think, and I've written about this, but I think a lot of data that looks batchy or is not actually batch data. Like let's say, for example, the typical example of like an OLTP database, which you extract data from Fivetran as like a batch sync. Really what's going on that OLTP database to generate the changes in the data are events are happening which are triggering transactions on that database. And that's why you're seeing like the proliferation of CDC as a way of moving that data, and therefore having data contracts on that stream. So that's one element I'd say about the batch part. Sorry, what was the first part of the question? I've forgotten it.
I think the other part of the question is, so how does the concept of contracts, which is basically codified formal definitions of data assets produced throughout the pipeline, applies to the more classic modern data stack world, right? So if we're doing something like Fivetran router stack, Airbyte data extraction, then using something like dbt on the cloud warehouse. Like personally, it's hard for me to see how that fits and how that's implemented unless all those vendors start talking to each other in something different than just SQL and kind of throwing tables around.
Yeah.
Is there a world like that, do we need this world? Do we need these kind of contracts in this modern data stack environment?
I think I think maybe this is one where maybe, like if you think about a DBT model, which is a table, right? I guess that is a true batch process, right? You've just run a query on the previous tables and then made the new table with it. And I think one of the reasons, or one of the ways you could implement a data contract there, is to have like a true unit test, because DBT tests currently are more like quality tests. They're not unit tests. So if you had a unit test where you said this model is actually a function and we have this static input that we're going to pass into the function and we expect this static output, then you could actually say, well, this function meets the contract, this model meets the contract. But we don't. Well, you could do that today. You could build like these static sets, store them in Snowflake somewhere, and then have your result set to compare to as well. You could actually build that in DBT today. It's just not natively supported out of the box.
Yeah. Right. We actually had Michelle Ark from Shopify present previous data quality meetup exactly that solution. So at Shopify, because they have such an enormous data volumes, they're not using DBT tests on actual data. They use it on synthetic data sets, just like you suggested, David. Yeah. I think we are. Yeah, I think it's actually surprising that we're not really approaching data testing from more like classic software engineering, fixed inputs, fixed outputs, kind of approach, right? I'm also curious, to the extent that data contracts are needed for reliable change management, I'm really curious to hear from Richard and Michael, given that you're working in an organization which is very large in terms of the number of people potentially affected and using data products. How do you approach change management given just the amount of data and complexity of data that's coming in and number of consumers that you have downstream?
Yeah, so I can probably comment one or two things on that. So yes, as you know, like telecom is like just lots of old school stuff, right? All over the place, everywhere. But there's lots of databases like Oracle, even DB2 on mainframe, believe it or not. But there are still modern technologies that can solve this problem. So we use Shrim on a lot of the on-prem existing data sources from Oracle. So those are actually replicated by binary logs using the trail files into BigQuery directly. But there's many different products, right? So I'm not like expert in data contract, but I think in my opinion, it's the easiest thing is to be able to manage those kind of using binary logs to make it automatic for majority of the use cases. Backwards incompatible changes, especially in a large organization from these databases, is extremely unlikely because you have because we actually look at the statistics of those things is extremely unlikely because the amount of things you break because of these kind of changes is so enormous. So that is actually a problem that is a very, very small chance of happening. So it's not almost not worth solving. So, but the majority of the use cases, whether, for our use case, we use Stream at the moment, but there's other things like Fivetran, other people, other guys I mentioned about. There's also Google Data Stream that quite limited, but it's kind of getting there, right? So, but by utilizing those kind of things with the binary log changes capturing, it actually handles the schema changes very reliably. All of these things are actually in the form of events. So in the BigQuery concept, they're all getting streaming inserts into rows on top of each other and append only. But these tools often have capabilities to send these as messages into event streams, such as PubSub or Kafka or other things, right? So you actually always have this kind of event driven with the schema is there, right? Because it's relational database where it comes from a lot of these data sources. Whereas for other things, maybe comment on batch sort of things, in my opinion, it really depends on how important that data is to you. So you might think there's lots of them, but actually the ones that's so valuable, that transactional data that you can't break, they're actually usually not that many from my experience I've seen. So I think it's important to prioritize whether you actually can store the data in a semi-structured way. For example, BigQuery has recently announced something called a JSON data type, which you can actually do tree-based lookups to even save your cost on that, which is extremely clever. And then those things, like you can, for things that are not extremely important, you can actually get them ingested as JSON data types, which you can actually define a schema afterwards. But for super critical stuff, whether that's batch or real time, you probably want to make sure like transactional data, transactions is specifically of people's orders, you probably don't want to mess around with not having any contracts. But I think that's my opinion. I don't know, Michael, if you have anything to add.
Yeah, no, yeah, I think I share the same sentiment. Yeah.
I think, Richard, you brought up an interesting question of knowing the criticality of data. I think that what's interesting is that it's one of the reasons why kind of the ideal data contract seems appealing is in large organizations, you may not know the impact of all the data you build, all the data you have, because people may build dependencies that you necessarily are aware of, unless you have a really good system to actually understand all the usages. I'm just curious how that works in your organization. Like, let's say someone builds a really important application, be that exec-facing dashboard or machine learning, would your team necessarily know about it? Or how does the process work so that you're not basically accidentally become accountable for data that someone is now using for critical applications?
So this is very interesting question because we as a data platform function that we look after we call it kind of data democratization as a buzzword in a sense. So it's basically kind of we have like a core data modeling functions. So there will be things that are experimentation based, like we strictly control, or I wouldn't call it control, like work with other teams. If there's a service account involved on automation, that we're very careful with those areas, and then we share data by kind of like a data mesh way in a centralized area, or in the GCP space, it's like we have a dedicated project called Customer Data Hub. That's where we only have authorized views in BigQuery to share that data, so it's all contract based. There's no exceptions but there are other areas where people are quite free to experiment, including some DBT project if they're on UAT. That's fine, right? But when people start building, downstream systems, I think reporting is probably just one side of the things that, to a degree, may be important. But the more important things are live machine learning models, and also we have so much operational workload, including communication to customer using a lot of this data we have in the first place. So these are very strict defined contract. But we basically created a self-service framework for people to do permission management via Terraform and pull request based. So we have approval groups who know what they're talking about, and then we have Confluence document to do what are the criteria. So you're right, it's very difficult to control, but if you have a platform team that is as evangelist working with the rest of the teams to basically making sure we know what the important ones are. There's no surprise. We never open up data lake, just there you go. Of course, like that you would end up with lots of problems, but we try to collaborate. What we don't do is we don't try to control everyone to experiment. You can experiment a lot of these things, but as you start building on the production use cases, the tangible stuff, it actually reduces, right? It's not actually that many, it reduces a lot. So that's where we started putting a bit more control in place to make sure the quality of those data sources.
Makes sense. So basically, you can try, but if you really want to put it into production, then you have to go through pretty much like an official request for building, and then you kind of pretty much have a contract this way, which it's very interesting.
It's because we're in a regulated business, so we can't just do whatever we like, right? There's lots of things we need to work with other teams, including privacy compliance, to make sure we follow the legal advices and regulator advices. So it's not there's data ethics and all sorts of things. So experimentation is fine in a restricted space where permission is given to those data points. But when we start unlocking, activating data points, is where it's tightly controlled on. Exactly how we can expose those things, because otherwise it's not just about things are broken, you can break the law as well. So it's very important to keep these things into account to protect our customers' data.
Makes perfect sense. I think what's also interesting to explore in that area is to what degree data quality is a problem that the data team ultimately is fully responsible for, because I think that in the current conversation around, well, why are we even talking about data contracts? It's because we have teams who are producing data, and then they are a lot of times not really fully aware of the usage of data, so they're changing things all the time, and then we data practitioners need to clean up the mess, and we are basically we are yelled by stakeholders, and then we are getting blown up by the software teams, and we're kind of like in this really vulnerable position. Like, do we believe that who is ultimately responsible for instrumenting reliable change management, quality, observability of data? Is it like platform team? Is every data pod is responsible for their own thing? Is it like, are we actually going to have software engineers implement certain quality solutions, or ultimately like who needs to take responsibility for that? Is it like a central thing or more of centralized?
Oh, is that a question for me?
Everyone, but yeah, if you have ideas, Richard, definitely welcome.
Yeah, I just want to give others a bit, but I'll probably add one thing. So in my opinion, it's more of I definitely think it's decentralized, because otherwise you can't scale as a function, right? So especially in a large organization, it just can't be a centralized team doing everything. So the approach we're adopting is more of it's very key to define ownership of SMEs. So the centralized team, we kind of, what we're trying to do is we kind of allow the individual experts in their area to build, but then if we identify areas that people are duplicating work, and then we start trying to over time pull a little back a bit by bits. So that means we're not actually slowing down everybody, and especially when some of the areas that kind of become independent functions. But one of the key things is, if you're going to build it, you have to own it, right? This is our only, I would say, policy in place. If you want to build it and you don't want to own it, then that's taken away from you. So the power. So if you build it, you own it, right? And then if there's a mess, we're not going to, as a platform team, we're not going to clean it up for you, but we have guidelines. And then we say, okay, if you two are both doing the same thing, because we see everything, right? We are evangelists and helping others to work together. And we see, oh, these two teams actually not working together. Can we actually, help you to work together? And then we have one centralized data models, and then we bring things in the centralized team that you can work on other things on top of it, right? Then so in this way, you can not only move fast, but also not have a mess down the road. Well, that's from my perspective.
And for me, I think it's a matter of ownership, like Richard says, because I think that when something fails about data, it is just like the data team which is in the light spot, but everyone shares this responsibility to give a good data to the data team. So when we have like a ticket in a software problem, and we will end up by the documentation, we should also communicate about the change that we will apply to the data for the data team. And in Doctolib, what we have is that for batch data, for example, we will have a system in data to protect ourselves, to detect the changes that could happen to the database that we are pulling data from. So it is a mutual work with the software team and the data team to just detect those changes, and we have a automatic pull request that will like change the structure. Then Redshift won't fail at the production, and it is kind of a data contract for batch. And for streaming, we could have another sort, because we could have an API that have data validation. So if the structure is not what we expect, so they have status, error status, so we can control what we have in streaming. So we handle it like that.
Yeah, at Convoy, we've, as a platform team, have kind of taken the responsibility of developing the tools, but like Richard said, we need to take a decentralized approach to kind of the ownership of these things in order for these processes to scale. So the platform team at Convoy develops the tooling that allows people to ensure data quality, but then in the case of data contracts, the ownership of the end data products, so your ML models, your executive dashboards, those are owned by folks on the data side, on the data team, but the people who are producing data for those kind of critical production path pieces of data, like the data that is generated to train our pricing models at Convoy to know how we price shipments, that is then owned by the software engineers, but the data platform team provides the tooling to make everybody's job easier on that front.
Got it. So basically the importance of the platform team, basically the platform team is the driving force for establishing the guidance for both the kind of applied product facing data teams who are building stuff using data, and then also pushing these guidelines to data producers like software engineers. It sounds like this is a kind of prevalent structure across what you three shared in your organizations.